It's Friday, May 26th here at Rocket Lab Mission Control as we await the liftoff of our 37th Electron launch, once again from Pad B at Launch Complex 1. Hello and welcome to Launch Day. You're joining us live for our broadcast of Coming to a Storm Near You, a dedicated launch for NASA to deploy the second half of the TROPICS constellation. I'm Imogen Ray.
And I'm Keegan Black, and we're excited to have you join us for another TROPICS launch. It's also an extra special day for us here at Rocket Lab as we celebrate the 6th anniversary of Electron's first launch. We're targeting liftoff for 3:46 p.m. New Zealand time, which makes it a late launch for our West Coast US viewers at 8:46 p.m. Pacific, and a super late 11:46 p.m. Eastern for our East Coast viewers. Whatever time it is where you are, thank you for joining us, and we hope you're well topped up with coffee.
Today's launch is the second of two for NASA to deploy the TROPICS constellation, which stands for Time-Resolved Observations of Precipitation Structure and Storm Intensity, with a constellation of smallsats. This innovative constellation of 4 CubeSats will monitor the formation and evolution of tropical cyclones, including hurricanes, and will provide rapidly updating observations of storm intensity.
This data will help scientists better understand the processes that affect these high-impact storms, ultimately leading to improved modelling and prediction to help save lives. Here's more from NASA about the TROPICS mission.
Here's a question. How does a group of satellites, each no more than a foot long, help improve forecasts for tropical storms and hurricanes? Let's take a look. Hurricanes are some of the most powerful and destructive weather events on Earth. The 2020 Atlantic hurricane season was brutal, producing a record-breaking 30 named storms. What's more, 10 of those storms were characterized as rapidly intensifying, some throttling up by 100 miles per hour in under 2 days. Many weather satellites will generally measure a storm only once every few hours, leaving gaps in coverage where a storm may quickly strengthen. To help fill this observation gap, NASA is launching TROPICS, a collection of satellites designed to make a big impact on our understanding of damaging storms. Their mission? To provide near-hourly observations of a storm's precipitation, temperature, and humidity, allowing scientists to better understand what drives a storm's intensification. To achieve this, researchers at MIT's Lincoln Laboratory developed a miniaturized microwave radiometer that's about the size of a cup of coffee. This small instrument will measure storm strength by detecting the thermal radiation naturally emitted by the oxygen and water vapor in the air. As Earth's climate continues to change, cost-effective but powerful satellites like TROPICS will be an important tool to help us better observe developments driving rapid changes in powerful storms, and help forecasters better predict and prepare for the weather ahead.
We are so proud to be supporting TROPICS and grateful to be once again working with our mission partners at NASA.
Just over 2 weeks ago, on May 8th, Electron lifted off for the first of these 2 dedicated launches and successfully deployed 2 TROPICS CubeSats to a 550-kilometre circular altitude above Earth at an inclination of about 30 degrees. All 4 of the TROPICS CubeSats need to be launched to their operational orbits within a 60-day period, but the sooner the better, which is why we're back on the pad just 18 days later, ready to go to space again. Let's catch a replay of that mission. Rocket like a hurricane.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have liftoff.
Vehicle has cleared the pad, safe for launch pad. Beginning pitch over.
Stage 1 propulsion is nominal.
"15 seconds to MECO.
Stage separation successful. Pairing separation successful.
Stage 2 propulsion still nominal.
HVB discharge nominal, approaching hot swap in roughly 30 seconds. Pulse wall successful. Battery jettison confirmed.
Payload deployment confirmed.
TROPICS has been a massive team effort with the science team led by the Lincoln Laboratory at the Massachusetts Institute of Technology and others including researchers from NASA Goddard Space Flight Center, the National Oceanic and Atmospheric Administration, or NOAA, and several universities and commercial partners. So with one launch down, we're excited to get the next away today ahead of the North American hurricane season.
Just like our first TROPICS launch, today's mission is flying from Pad B at Rocket Lab Launch Complex 1, our private orbital spaceport on New Zealand's Mahia Peninsula. As we approach the final minutes in the countdown, our launch operators at Range Control in Mahia and here in Rocket Lab's Mission Control are working through their final checks before liftoff. Commanding this overall effort is Launch Director Julia Van Bacher.
Shortly, Julia will ask all operators for an update on their launch status to determine if they are good to proceed with today's planned launch. This is called the Go, No-Go poll, where operators will indicate if their systems are green, go for launch, or red, which means they're working an issue. Let's listen into that poll for all greens and goes across the board.
This is LD on mission code. We are proceeding now with the Go, No-Go sequence. Stage.
Stage is go.
Avionics.
Avionics is go.
GNC.
GNC is go.
Recon.
Recon is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET. MET polling for Go, No-Go. Coming back later to MET. RF. RF LD and mission code.
RF is go.
Thank you. MM
MM is go.
and MET.
Mid is go.
LD sub.
LD sub is go.
The Go, No-Go sequence is now complete. We are T-minus 11 minutes and 58 seconds in counting. We are go for terminal count at T-minus 10 minutes. From this time, the three-way procedure is in effect.
Fantastic news there from Mission Control. All greens across the board, which is what we want to hear. We are go for launch, which means we are coming to a storm near you very soon indeed. We're on track for a liftoff of 3:46 p.m. New Zealand time today, in about 10 minutes from now.
Today, with this TROPICS launch, we're also celebrating a special anniversary for our favourite rocket. On May 25th, 6 years ago from Launch Complex 1, Electron took to the skies for the very first time. As it crossed the Kármán line and completed a perfect first stage burn, stage separation, second stage ignition and fairing separation, Electron became the first orbital class rocket successfully launched from a private launch site and opened up a new era in regular and reliable launch for small satellites.
The flight also ticked a few other world firsts. The first launch for an all-carbon composite rocket with the world's first 3D printed engines, powered by a completely new electric pump-fed cycle. 36 launches and 161 satellites deployed to space later. Today we're ready to launch our latest pair of sats to space on Electron and wish it a very happy 6th launch anniversary as it flies.
Today's launch will be our 37th Electron mission, but the way we go to space for the two TROPICS launches is a little different from a standard Electron mission to low Earth orbit. The launch follows a standard format for the first 6 or so minutes of the mission. Electron will lift off from the pad thanks to the 9 Rutherford engines on the rocket's first stage. These engines will burn for around 2.5 minutes, lofting Electron to about 90 kilometres above Earth's surface. From here, Electron's first and second stages will separate, with the spent first stage falling back to Earth. Shortly after this, a single vacuum-optimised Rutherford engine will ignite on Electron's second stage to propel the kick stage and TROPICS CubeSats for another 7 minutes, positioning them at that 550 kilometre altitude.
This is where the mission departs from our standard format. Typically, Electron's second stage takes the kick stages and payloads to an elliptical orbit, and we use the small 3D printed Curie engine on the kick stage to circularize the orbit. For the TROPICS launches, the second stage is used to circularize the orbit, and instead, the kick stage's Curie engine conducts what's called a plane change maneuver to position the TROPICS CubeSats at an inclination of 30 degrees, the best spot for monitoring the formation of tropical storms. Here's more from Guidance, Navigation and Control Team Lead, George Buchanan.
I'm Dr. George Buchanan, Guidance, Navigation and Control Engineer, Team Lead, but you can just call me George. The G&C team, Guidance, Navigation and Control, is in charge of making sure that Electron gets to the right orbit. So the inclination of an orbit is the tilt. So a 0 degree basically means that you're going all the way around the equator. 90 degree means that you're going up and over the North Pole and the South Pole. So with a normal Electron, we'll go to a transfer orbit with our stage 2. So that means that we're in around about the right orbit, but slightly too low, and then we use our kick stage just to boost us up before we deploy payloads. So for TROPICS, we've got to do a couple of sneaky things. So firstly, we do a dogleg, which is basically where our trajectory actually bends around, and so we head up north rather than heading out east, and then we sort of curve as we're flying. And then the second thing which we have to do is we use our kick stage to do an on-orbit inclination change, which basically tilts the orbit which we're in to be in the right one. So for TROPICS, between liftoff and payload deployment, most of it will look very similar. However, what's a little bit different for TROPICS is that we'll be at the right altitude already. So if you're watching, you look carefully at the video and also at the altitude overlay, you'll see that we're much higher than normal. So we go into a coast until we get close to the equator, and at that point our kick stage will light its Curie engine and do an inclination change. We'll actually be pointing sideways and burning sideways. So we'll be travelling up along this way and actually thrusting at right angles to that, which is highly unusual, but it's what you need to do this change. Shortly after that, we'll do a payload deployment. And so we'll actually be deploying outside of ground station range. And so we won't have live confirmation of that until we get over our ground stations in Europe. Yes, so we've done this manoeuvre before. In fact, we did it for the first TROPICS mission just a couple of weeks ago. And we expect it to do exactly the same thing. We'll head up north, do a dogleg, inclination change, and deploy some more satellites into orbit. What the kick stage gives us is a lot more flexibility on orbit, and so we can do a lot of missions which a traditional large launch vehicle may not be able to do. So we can wait before doing burns, we can light up to dozens of times with this little kick stage, and we can point it in any direction we want to. It's also fairly flexible because it's this photon bus, we can change it. So sometimes we'll add additional batteries so we get a longer mission, or we'll change the amount of RCS if we want to do a lot more manoeuvring and pointing. When a customer comes to us with some interesting requirements, then we sit down as a team and work out how we can get Electron to meet these. And so this will be doing a bunch of simulations to make sure the trajectories will get us to the right orbit. We'll also run tests on actual hardware to make sure that we can meet any requirements that way. Sometimes we'll do things like change the design of the vehicle, so we'll be talking to other teams. And this is something which Electron, being quite customizable and being really agile, is great for. Yeah, I really love these science missions. Being able to do something which is actually going to have a really positive impact on millions of people. It's something really special.
We look forward to hearing confirmation in around 30 minutes from now that the kick stage has completed that plane change manoeuvre and the final TROPICS CubeSats are safely in orbit.
We're just 4 minutes away now from launch. 2 minutes before liftoff, the ground power supply at the launch pad is disabled and Electron switches to internal power. Our launch safety system, the Autonomous Flight Termination System, will be enabled at the same time, and we can expect to hear both of those calls from our operators in mission control. The liquid oxygen supply valves on stages 1 and 2 will be closed a few seconds later, shortly followed by another operator confirming that LOX load is complete.
Then, with under 60 seconds to liftoff, the propellant tanks will be at their optimum pressure levels for launch. Ground control will then confirm that the water deluge system on the pad is ready to be activated for when the engines on the rocket ignite for launch. This is what will cause the large white cloud of water vapour at liftoff. At T-minus 10 seconds, you'll hear the launch director counting down to liftoff. Those 9 Rutherford engines we've mentioned before will ignite at T-minus 3 seconds and the launch pad's hold-down mechanisms will be released. Electron will then take to the skies for its 37th launch and the final TROPICS CubeSats will be on their way to space. Let's listen in for that final launch sequence.
To all operators, this is LD on mission code. From now on, there should be no red flags on your critical LCCs. VCON LD on mission code.
LD VCON.
VCON, please lock the auto sequence and confirm.
Confirmed.
Thank you. And VCON, please confirm that all expected primary flight computer ASCOs are green.
Confirmed.
Thank you. To everyone on mission code, we are go for auto sequence start at T-minus 2 minutes. LDs go for launch.
Vehicle is on internal power. AFTS is green and ready for launch.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1, Stage 2, press for flight.
High purge flow, engine purge enabled. Deluge activated.
And T-minus 19 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
HVB discharge nominal.
And that is a beautiful liftoff for Electron. The final 2 TROPICS satellites are on their way and coming to a storm near you. With Electron now having cleared the pad, the next milestone is max Q. This is the point where the forces on Electron are at their greatest. So we'll listen out for clearance of that key moment from Mission Control soon.
Max Q.
clear at max Q.
Stage 1 propulsion is nominal.
And there we have it. Electron has passed through max Q and continues on the way to space. Right now, Electron is traveling at over 2,000 kilometers per hour and is at an altitude of 20 kilometers.
Now, coming up next is main engine cutoff, or MECO, where the 9 Rutherford engines on Electron's first stage shut down to make way for separation between the first and second stages. Within seconds, the single space-optimised Rutherford engine on the second stage will ignite to carry the kick stage and the TROPICS satellites all the way to orbit. That should take place shortly at around T plus 2.5 minutes. So let's listen in to that call from Mission Control.
Stage 1 propulsion still nominal. Please stand by for MECO in roughly 30 seconds.
$15 seconds to MECO.
AOS at Chatham Station.
Entered burnout detect mode.
And MECO confirmed.
Stage separation successful.
Stage 2 ignition.
And just like clockwork, we have had MECO, Stage 1 and Stage 2 separation, and ignition of Electron's second stage. Coming up very shortly, we'll also see Electron's fairings separate and fall away. These two carbon composite halves form a protective nose cone over the TROPICS satellites, keeping them safe during ascent. Once we're in space, though, they're not needed as the forces on Electron are not nearly as great. So we can get rid of them and clear the way for payload separation. Now, for this mission, because we're headed to that 550 kilometre circular orbit straight away with Stage 2, we're leaving the fairing attached just a little bit longer than usual. That jettison event should be coming up in the next 20 seconds or so.
This is nominal.
Fairing separation successful.
And that's fairing separation confirmed. We are at 4 minutes into flight now, and coming up next is a process unique to Electron, battery hotspot.
The pumps on Electron's Rutherford engines are powered by electron pumps, which draw their energy from batteries. Once we deplete the batteries, they are dead weight that we don't want to carry all the way to orbit, so we eject the batteries and swap over to a fresh set in flight. That milestone is coming up just before 7 minutes into the flight, so still a ways to go yet. So far for today's mission, we've had a perfect liftoff. We've cleared max Q, had a good first stage burn, and separation of Electron's first and second stages. Fairing has also separated as planned, and now we're 5 minutes into the mission.
So far, a nominal mission for Coming to a Storm Near You, the second of 2 dedicated launches to deploy a storm monitoring constellation for NASA.
Stage 2 propulsion still holding nominal.
Guidance is nominal, 200 seconds remaining.
Now we're coming up on that all-important battery hot swap. Powering engines with batteries is one of the things that makes the Rutherford engine special. The single Stage 2 engine requires a longer duration than the Stage 1 engines, so we have to hot swap the spent batteries to a third fresh one. This is one of the final gates to orbit, so let's listen into the operators in mission control for that call.
Nominal approaching hot swap. Throttling down. Swap successful.
And there you have it, a
Propulsion is
clean
nominal.
hot swap for the second
That
stage
engine is
Rutherford engine.
confirmed.
Electron continues to orbit with around 2 minutes remaining in today's Stage 2 burn.
Speed is good, altitude is good, Electron is good, T plus 7 minutes into the second Tropics mission for NASA. Just in time for the Atlantic hurricane season commencing at the start of June, these two CubeSats, along with the two that we launched just 18 days ago, will provide members of the meteorological community with hourly returns over the same storm to more accurately predict patterns, which could save the lives and livelihoods of millions of people.
T plus 8 minutes in, and we are now around 30 kilometres away from that 550 kilometre target orbit. As George mentioned in the video earlier, this Stage 2 burn is taking us all the way to a circular orbit. Then we have that dogleg inclination change just over the equator to put us in the correct plane for payload deployment coming up at 33 minutes into the mission. Electron is continuing well at speeds of over 19,000 kilometres per hour, ahead of SECO and kick stage separation.
SECO stands for second engine cutoff, and you'll know when the second stage completes its burn because the nozzle glowing bright orange on your screen right now will turn back to grey as it cools down after the engine shuts off. Immediately after that shutdown, Electron's kick stage separates from the second stage, and in around 1 minute the Curie engine will ignite and begin that plane change manoeuvre ahead of payload deployment. Again, mission control will call out these actions, so let's listen in for confirmation of SECO.
SECO confirm.
Stage 3 separation confirmed.
Nominal transfer orbit achieved.
And that is SECO confirmed as planned. The kick stage has also cleanly separated, ready for that final Curie burn in around 20 minutes from now, followed by payload deployment at T plus 33 minutes. Because this final burn and deployment of the TROPICS CubeSats happens in a ground station blackout zone, we won't get live confirmation of those milestones. We also won't have live video footage of the deployment process. So here's a quick animation to show you what will be happening in orbit just 25 minutes from now. Since we won't have live coverage of payload deployment, we'll take a short break from the broadcast and join you again in around T plus 45 minutes to provide an update on deployment and to confirm mission success. We'll leave mission control comms up during this coast phase so you can hear it as soon as it happens. We'll be back with you soon.
Expected Curie ignition. Expected Curie shutdown. Expected payload deployment.
TCLD on range. Sorry, on mission. Disregard.